So one of the keys to the 3D scanning surface mode is part detection, and we saw that a little bit, but I want to show you how that really works with multiple objects. So if we go into the part detection area and we scan some parts, we're going to grab a few items here. There's a thing called gap width and gap length. I'm going to take three objects. There's three different types of objects here, and we're going to place them around in a sort of a small cluster, and we're going to increase the gap width and gap length criteria here. I'm going to put that up to about 25 millimeters. What this really means is that when we scan an object, we can actually separate objects from each other by finding gaps, and this allows you to adjust what those gaps can be. So when I raise this up to 25 millimeters, it means that it'll actually bridge the gaps between the parts. And so if I scan over this scene, we're going to see a 3D scan that actually is really one image of the three objects. However, I can actually separate these objects from each other and provide tools on them. And the way I'm going to do that is I'm actually going to use the recording feature on our sensor. So this sensor has the ability to record data and play it back so that the user can help develop their application. So what I'm going to do is I'm going to press record now, and I'm going to scan over these objects again, except I'm going to reduce the gap criteria to something very small, like 3 millimeters. And the recording will allow me to play them back and see those three objects as they scan them. Because now with the smaller gap criteria, we're actually going to separate these objects, and you may see them come onto the screen. We'll look at them after we've scanned the whole scene here through the playback. So up at the top here, you'll see it says 3 of 3, so we've actually found 3 different separate objects. And if I go into the replay, we can look at those. So we see the wire nut that we have, and then this sort of hex screw, and then this ring. Those are 3 separate objects. Now, you'll notice that they kind of move around on the screen, and that's because they're at various positions on the table. One way to kind of center them is to use what's called the part frame of reference, and this helps us actually apply tools to these objects individually and know that they're in the right spot. So if I select part selection, and I'm going to go back into the scan mode, and now I'm going to replay again, and we'll scan over this again with part frame of reference, and we'll see these objects come up on the screen again. And I'm going to go and replay them, but now as we look at these objects in replay mode, we'll see that now that they're centered on the screen. So there's object 1, object 2, object 3. And I can now apply tools to them. One key tool here for these objects, let's say, would be what we call the bounding box. Let's say I want to know the size of these objects, their length and their width. And so I'm going to put a bounding box to this wire nut. I'm going to raise it up a little bit bigger. And I'm going to have this box tell me where it is in space, X, Y, Z, and its width and its length. And maybe I've got some sort of pick and place application where I want to find these objects, understand their shapes, and then pick them up and put them in reject bins or accept them. So if I now look at this, I can actually select rotation. This will actually rotate the bounding box around the object. So you'll see that I actually have a X, Y, Z position. I can get its global X and Y in real space, and I can get its width and length. But because I scanned 3 objects, we have this data for each one of the objects. And so if I had a wide array of objects on a wide conveyor, the fact that we have part detection with the gap criteria settings means that we could look at multiple objects at the same time. There could be 5, 6, 7, 8 objects across the width of the belt, moving at a rate of speed, and as each object left the field of view, we'd be able to apply our measurements to that object. So that's a real key feature inside the Gocator, the part detection, which allows that to happen and actually makes it much easier for the user to obtain those measurements without having to scan the entire scene and then find those objects. The sensor actually does it for you. Okay, so those are some of the surface tools that can be created. And those tools can be anchored just like the profile tools. So you can use, for instance, the center of a hole as an anchor to locate another feature box of another tool. anchors can be nested, so you can have an anchor of an anchor. However, when we're doing surface mode and we have products that might come down in various degrees of rotation, we need to be able to also rotate them. And one way to do that is through our, what we call our model screen and some part matching. So if I enable this part matching and I scan an object, I'm going to scan this screw, which looks like this. And I'm choosing this because I can make it sort of asymmetrical and we can show how it might be rotated. So I'll scan it. And we're going to use this scan as a part match. So if I enable this, you'll see this is on some sort of degree of some sort of random rotational degree. I can use a bounding box, which will actually take this and turn it horizontal. It basically takes the bounding box, finds the long axis, and makes that on the horizontal axis. This means that if I rotate this around at different degrees and I rescan it, it'll keep its orientation. This allows me to create tools and put them in the right degree of rotation so that they're in the right spots. So I'm actually measuring the parameters that I want to. Now, the problem with this particular bounding box is that I can actually cause it to reverse polarity. So if I scan it this way, we've actually flipped this 180 degrees. So if it's fairly simple what you're trying to do, bounding box works quite well, but we do have a much more detailed way to do rotation, and that's through edge-based pattern matching. With this type of pattern matching, I can actually find the object and essentially stop and then add that scan, and I've now got a model inside the Gocator. I've basically taught it this model, and I have various parameters that I can use in terms of sensitivity. I can go in and I can add edges or remove edges, and once I do that, I save that model. And now if I use this and rotate my object, it will use that model to rotate it. So I'm at a specific, you'll see I moved the object, but my rotation of that object did not move. And as I rotate around in different degrees, our model stays in its current rotational configuration. So this will allow me to scan various objects that come down, and they could be multiple objects, and each of those objects could be in different degrees of rotation, where our model will then rotate it to a proper degree. We can then apply our tools and create our outputs to measure our objects. Okay, so that's a good look at the Gocator feature set. So we can measure profiles, we can measure surfaces, we have part detection for surfaces, we can rotate those objects, anchor them, and create our tool set to measure the parameters that we're looking for. Now we don't have every tool created, but we have created a large set of profile tools and surface tools for various features, and we add more all the time. But sometimes users want to actually just take the data, bring it to another tool set, external software, or use our software development kit. I'm going to go quickly into another scan. In this case, I'll scan this connector rod again, just to kind of show that image. And as you recall, this is really a 3D height map. So if I look at that image again, this is a height map where the pixel value is height. And some users will actually take this image file and process it in various image processing software packages. And LMI has written drivers to get into things like Halcon, Common Vision Blocks, which also gets us into DALSA Sherlock. We can get images into LabVIEW and various software packages, and we're adding more drivers to get into software packages that other users are familiar using with. And other users will actually use our open source software development kit, which allows users to bring in full point cloud data and write their own algorithms inside. So if you don't have the tools that you feel that you want to use in our feature set, you can actually export this data to use your own tools. Another thing that's quite interesting is that not only can we measure 3D information, but we can also get some 2D contrast information. And to show you that, I'm just going to take a business card and let's lay it on top of this object. And up here, we're going to click this thing called Acquire Intensity. And so I'm going to scan over this again, and we're going to see a 3D map of this. You can actually see the business card on there. And I may not have the perfect exposure for this. I could probably optimize that. But this is the 3D map of this, 3D height map. And if I load it up in my 3D rendering, I can rotate it around. You can see how the business card's laying on top of there. But I can also look at it in a intensity plot. And so here's the intensity plot. This is the actual returned light intensity from the laser, and you can see that I can actually rotate this as well. And so not only can you get 3D information, you can also get some 2D information at the same time. It kind of comes along for free, and you can use that to process some grayscale type features. Now this resolution here is really based on my encoder resolution, so I can actually either move slower or increase my speed, and I get a much tighter resolution for that 2D image as well.